Hi guys, welcome back to the channel. My name is Jag, and in today's class we're going to continue with our Chemistry 11 content, and we're moving on to the next unit. And this unit is on molar concentration, and I'm going to write out the formula on the board. Okay, so this is the concentration is equal to N divided by V. Okay, so the N is the number of moles within the concentration of the solution. Okay, V represents the volume, okay, and the volume has to be in liters. So again, whenever you're doing any types of mixtures and stuff within the laboratory, you are going to use milliliters, okay, as you're using a beaker or like a graduated cylinder, it's in milliliters. Make sure you're converting this into liters. Okay, so if I'm looking at this formula here, I can see that the concentration of a solution is in moles per liter. Those are the units. Or some teachers do use molarity. Molarity is just the capital M. Okay, so with that, we're going to go through a couple of examples, okay, from the textbook here. So I'm going to take this off. All right, so I'm going to read the question out loud. It says a saline solution contains 0.90 grams of sodium chloride, which is NaCl, okay, just in case we're not sure. And it's dissolved in 100 milliliters of solution. What is the molar concentration? Okay, so first off, we have sodium chloride. So the first thing we want to do is actually the molar mass, okay, of sodium chloride. So remember again, when we are looking for the molar mass, we're just using the values that we have within the periodic table. Okay, so we're going to do 23, okay, plus 35. Okay, and again, make sure you are just rounding, okay, all of the numbers in terms of the values. So we're just rounding, the sodium is actually 22.99. I'm rounding that to 23 here, okay? And chlorine is 35.45, and we're rounding it to 35. So again, if your teacher wants you using exact values from the periodic table, then that's what you should do, okay? So we're just gonna add that together. I'm getting 58 grams per mole. Okay, and again, make sure you are writing down the units for the molar mass, or the teacher will take marks off. Okay, so that's the first thing we are doing, and it's always the first step. Okay, you're always looking for the molar mass before I can actually even utilize the other formulas in the units. All right, so in the next step, what we should do is perhaps look for the number of moles. Okay, I'm going to put moles of NaCl, okay? Again, when you're looking for the moles, remember it's the mass divided by the molar mass. Okay, so I do have to make sure I am remembering this formula, and we can see that we use that in Unit 3. We're continuously going to be using it again in Unit 4 as well, okay? So don't forget the formula, and make sure you're memorizing them. Okay, and so we're going to do, it gives you the solution contains 0.90 grams of sodium chloride. So I'm going to do 0.90 over the molar mass we got from step 1, okay, which is 58. So we're going to do 0.90 divided by 58. And again, I am going to round this. So 0.0155 moles. Again, I always tell students to leave several decimal places. The reason for that is to make sure that your answer is accurate until the very end. Okay, so this is the second step that we did. Okay, and lastly, in this step, we are looking for, it says, what is the molar concentration of the solution? So I'm going to put C equals N divided by V. I have my moles from step 2, so 0.0155. Divided by the volume. The volume is 100 milliliters, and we are just going to divide that by 1,000, okay? So it's going to be divided by 0.1 liters, okay? And that's all we're doing here, okay? Make sure you're just changing the volume from milliliters into liters before you plug it into this formula, okay? And we're just going to divide this, and we are getting 0.16 moles per liter, okay? And again, check with your teacher in terms of like rounding. It is okay if you round the concentration to 2 decimals. Okay, I think it is actually more accurate if we're rounding it to 1 decimal. And the reason for that is when, again, you're using these different structure or substances in the lab, and within the laboratory, the actual container will just say capital M with the molarity, okay? So again, just check with your teacher. You don't want the teacher taking off marks for something like that. Or it might even be due to the sig figs, which is the significant digits. And a lot of chemistry teachers are very picky about that. Okay, are there any questions? Good, so let's try one more example here. Okay, so I'm gonna take this off. Okay, and this example looks similar to this one. Okay, but again, remember, using this formula for molar concentration, the teacher doesn't have to just ask you about what the concentration of the solution is. The teacher can also ask you what is the volume, okay, of the solution, what is the mass of the actual solute in the solution. So there are so many different variations to this question. Okay, if you get kind of confused, I would make sure I'm writing down what is given and then what is required at the very end. Okay, so let's try this question here. Again, I'm going to just read it out loud. Okay, so at 20 degrees Celsius, a saturated solution of calcium sulfate. Okay, so let me just write the formula here. Okay, it does give you the formula. So CaSO4 has a concentration of 0.0153 moles per liter. A student takes 65 milliliters of this solution and evaporates it. And what is the mass that's left over in the evaporating dish? Okay, so I can see right away, it's not even like the previous example that we just did. Okay, this time it's asking me for the mass of the solute that's left over. Okay, so with that, let's start. Okay, again, the first step should always be you calculating the molar mass of the compound. So I'll put 1 here. Okay, so molar mass of calcium sulfates. Okay, so again, calcium is basically 40. It says 40.08. We're rounding that to 40. Same thing with sulfur, 32.07. Okay, it's not going to make a really big difference. Okay, and I'm just going to put 32. Okay, oxygen we all know is 16. There are 4 atoms of oxygen, so 16. Oh, sorry. So I'll put plus 16 times 4. Okay, again, make sure you double check all of your answers, okay, for molar mass. If you don't calculate the molar mass correctly, everything else in the question thereafter will be wrong. Okay, so I'm going to add that up, and we are getting 136 grams per mole. Okay, does everyone see how to do that? So we're just taking some values here from the periodic table for each of the elements, and make sure you're multiplying it by the number of atoms. Okay, so I have the molar mass. All right, in the second step here, okay, what I would do is perhaps find the number of moles. Okay, I have the volume, okay, and I also have the concentration of the solution. So I'm going to actually write down, let's write moles, okay, of calcium sulfate. And again, I always actually like writing out all of my answers in these steps, okay? Students know I like seeing the steps written down, as well as you just kind of like writing out what is it that you're actually solving for. And that way the teacher can follow your steps up to like your final answer, okay? So I'm going to write the original equation here. It's C equals N over V. Okay, this time I'm actually going to look for the number of moles, okay? So instead, when I'm looking for the number of moles, again, just like in math, I should be able to rearrange the formula based on the variable that I'm solving for. Okay, so N is going to equal to C times V. Okay, and so here I have the concentration, so it's 0.0153, and times, the student is taking 65 milliliters of this solution to evaporate. Again, 65 divided by 1,000. Okay, so I'm going to make sure I write it in brackets here. Just 65. Okay, milliliters. And when you're converting it to liters, I'm just dividing it by 1,000. Okay, so I'm going to put this into my calculator. Okay, and we are getting, so I'm not going to round this. Okay, so 0.009945 moles. And again, I know some students do actually round the answer. I wouldn't round it in this intermediate step. or that's going to actually give you not the wrong answer, but your answer might be off by maybe a few numbers or a decimal place. And some teachers, again, are very picky. They will take off marks for that. Okay, so I just wrote down the whole number that I got on the calculator here. Okay, and in this last step, we are looking for the mass, okay? The mass that's left over in the evaporating dish. Okay, so I'm just going to put mass of CaSO4. And again, the mass is equal to the moles times the molar mass. And again, this is the actual formula that was used in Unit 3. And it's going to repeatedly be used in Unit 4 as well. Make sure you are memorizing it, okay? So I do have the moles here from step 2, so 0.0009945, and times the molar mass that I calculated in step 1, which is 136. All right, and so we're just going to multiply this, and we are getting 0.14 in grams, okay? And as you can see, again, when you're doing the number of grams, okay, I usually do round it to 1 decimal place, okay? So maybe we'll just put 0.1, okay, grams. And again, the reason is if I'm actually taking this substance and weighing it out in the laboratory, it's not going to give me an answer to 2 decimal places. It'll give you the answer to 1 decimal place. And that's actually very accurate, okay, when you're measuring out any of these substances. Okay, so this is basically my final answer. You can see as we're doing each of these questions in terms of calculating the concentration and the moles or the volume, there are variations for each of the questions, okay? I would make sure I'm doing these in steps, and I can see that there's only like 3 steps that I really need to do. By the time you get to the 3rd step, I'm just using the values from step 1 and step 2, and you can see I can very easily obtain my answer. All right? So if there are no questions, that brings this video to an end. Thank you for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone next time. Thanks. Bye.